Have you ever stopped to wonder who actually keeps a blockchain, well, running? Spoiler, it's not magic. It's a full-time, 24/7 job done by teams working deep inside what you could call the digital engine room. So today, we're going to go behind the scenes with a team called Karatage, and we're going to see what it really takes to keep the lights on for the Midnight Network. And trust me, this isn't just a story about code. It's a war story, straight from the trenches.
Okay, so first things first. What even is a federated node operator, or FNO? Well, think of them as the highly vetted guardians of a decentralized network. That federated part is key. It means they're part of a small, trusted group, handpicked to make sure the network is secure and stable. They are the absolute backbone. They are the infrastructure.
And this quote from Steve at Midnight, it just nails it. It really puts the stakes into perspective. They're in the engine room, and every 6 seconds, bam, a new block has to be produced. No holidays, no weekends off. If one of them stumbles, the whole network feels it. It is a relentless, high-pressure job that demands some serious technical skill.
All right, now this is where things get really interesting. See, Karatage isn't your typical tech company. They're actually a private investment firm. So you have to ask, right? Why would a venture capital firm, a group that usually just writes checks and looks at pitch decks, decide to roll up its sleeves and get its hands dirty in the engine room?
Well, it all comes down to a fundamental philosophy. Just look at the difference here. A typical VC, they're a passive participant. Karatage, on the other hand, wants to, and this is their own phrase, put our money where our mouth is. They don't just want to bet on some tech from an office tower. They want to be down in the trenches, running the code, and actually feeling the operational pain themselves. They believe that's the only way you can truly understand what you're investing in.
So out of all the projects out there, why Midnight? What did they see? They saw that Midnight hit this perfect sweet spot. It has a unique privacy model that gives you, the user, control over your data, but it can also meet the compliance needs of big institutions. They saw it as the key to unlocking fast, secure payments. And maybe the biggest reason? They saw it as building the essential rails for a future where AIs will need to transact with each other.
But having a vision is one thing. Actually making it work day to day is something else entirely. And that brings us to the war story. This isn't some theoretical problem. This was a real-world 5-alarm fire that threatened to kick Karatage off the network before they even really got started.
So that's the big question, isn't it? What happens when you're a critical part of that engine room, and your part of the engine just starts to sputter and seize up? When the whole system is supposed to be churning out a block every 6 seconds, and suddenly you just can't keep up. The pressure is unbelievable.
And this chart? Wow. This just shows you how bad things got. While all the other operators were humming along, finalizing blocks in a super fast 50 milliseconds, Karatage's node was taking, get this, 12,000 milliseconds. That's 12 full seconds. They weren't just a little slow, they were hundreds of times slower. At that rate, they were basically useless to the network.
So the team scrambles. They figure, okay, it's got to be a slow database query. The logical fix? Throw more hardware at it, right? So Luke, their head of engineering, spins up this massive, beefier server. And he's doing this at 1 o'clock in the morning while he's on a work trip in Namibia. But even with all that extra horsepower, nothing. The performance was still terrible. It wasn't the hardware.
It turns out the answer wasn't about brute force at all. It was something way more subtle, something hidden deep inside the software's configuration. In the end, it all came down to one single line of code.
Now, to get what happened next, you just have to understand this one little thing, the Postgres Query Planner. The best way to think of it is like a super smart librarian for the database. When you ask for some data, its job isn't just to go get it. Its job is to figure out the absolute fastest, most efficient way to retrieve it. It tries to outsmart the request. And that was the problem. The librarian was trying to be too smart. It was looking at this one database table that had over 1.2 billion rows. The index was so massive that the query planner was basically choking, just trying to analyze it to come up with a better plan. It was spending all its time thinking about the best way to do the job, instead of just doing the job. And this was the fix. This one little line of code. Join collapse limit equals 1. All this did was basically tell that overthinking librarian, hey, stop trying to be clever. Just follow the instructions I gave you, exactly as written. And boom, instantly the problem vanished. Block times dropped from 12 seconds right back down to milliseconds. Crisis over.
But for Karatage, just fixing the problem wasn't the end of the story. In fact, it was the beginning of a whole new strategy. They realized that every crisis, every bug, every fix, it's all incredibly valuable data.
So the question became, how do you build a system that can actually learn from its own war stories?
And this is their playbook. It's brilliant. They document everything, every incident, every fix, right back into their code repository, creating what they call a deployment journal. Then they use an AI, in this case Claude, to search through this entire history. The AI acts like a distillation layer, making sense of all this complex data. And this is the really critical part. They keep it safe by only letting the AI run from a library of pre-approved scripts, so it can't go rogue.
This quote from Luke just perfectly captures the whole goal here. It's not just about writing code anymore. It's about building an intelligent system that has a memory, a kind of institutional knowledge that you can literally have a conversation with. Anyone on the team can now ask, hey, have we ever seen an error like this before? And get an instant, context-aware answer.
And that really brings us to the final big idea here. Karatage's whole approach, building this AI copilot from their own operational history, it really feels like we're getting a peek into the future. You know, as these decentralized networks get more and more complex, is this blend of human expertise and AI-driven memory going to be the only way to keep the engine running? I think it just might be.